periodic table. You can tell a lot about an element by its location on the periodic table. The periodic table is an extraordinarily useful tool for chemists. Just by looking at the location of the elements, you can not only tell the characteristic properties of the element, but also predict how it will react with other elements. So let's become familiar with the periodic table. In 1869, Dmitry Mendeleev, a Siberian chemistry professor, developed a periodic table to reveal the repeating pattern of characteristics of elements. Where there was a gap in the pattern, he correctly predicted undiscovered elements. Mendeleev's periodic table organized elements by their atomic mass, whereas today it is organized by the atomic number. Of the 118 elements recognized today, 94 are natural elements and the rest are man-made. The man-made are created by scientists. Most of the man-made elements have an atomic number above 92. And we should zoom in here. Here are some examples of the natural elements. It'll be an example of aluminum, and then it would go to a picture of natural aluminum, and then go to a soda can, so the students can see, can relate to it. This one is going it's going to be about information about the man-made, such as maybe a process in terms of protons or short life, radioactivity. It is the main thing is to focus on how to recognize it on the periodic table in terms of being synthetic or natural, which will be looking at the atomic number. If it's less than 92, there's a good chance. We have a couple of others mixed in there. And also periodic tables that have radioactive signs that'll help them understand about radioactivity, not just with the synthesized ones. And of course, undiscovered by the 3-letter names. The periodic table was created to reveal the trends of the elements. And then here's going to be more sentences. This has to be real important. This might go really in the beginning, right? And also that your lower atomic numbers are on higher, and then as you get lower down to the end here, it is your lowest. We have 118, would go down to here. This one is going to be the explanation of the rare earth family right here, the lanthanide and actinide series, and how these will be fitting right in here. Groups. Elements are also organized in columns referred to as groups. Each group contains the elements connected vertically or top to bottom. Moving from left to right are groups 1 through 18. All the elements in a group have the same number of valence electrons. The valence electrons are the outermost electrons orbiting the atom. The groups are also referred to by family names seen when the arrow is dragged across the periodic table. Again, because the elements in a family have the same valence electrons, except for transition, they react very similar in certain situations. For example, the elements in group 18, the noble gases, are odorless gases that do not generally combine with other elements because they have 8 valence electrons and are stable. They are not looking to lose or gain electrons. Whereas the alkali metals family, group 1, have 1 valence electron and are all very reactive to water. Hydrogen does not belong in the alkali metals, although it does have 1 valence electron. Another exception. Besides the elements in groups sharing similar characteristics, the periodic table can be divided into sections where elements share similar physical characteristics. The 88 elements to the left of the stair-step line are metals. The few elements surrounding the stair-step are metalloids, and the 18 to the right are the non-metals. Most metals are malleable. They can be hammered into sheets, have luster, meaning they shine, are ductile, they can be drawn into wire, and are good conductors of heat and electricity. Metalloids, the 7 elements on either side of the stair step, are called metalloids. Should have started with the other one. These elements share some of the physical properties of metals and nonmetals. Silicon and germanium are metalloids, which are semiconductors and are used to make computer chips. The physical properties of most nonmetal elements are brittle, that means they break easy, are dull, not ductile, and are poor conductors of heat and electricity. The black carbon is brittle and dull. The helium in the balloon is a gas at room temperature, whereas metals are solid with the exception of mercury, which is a liquid. Another physical characteristic displayed on some periodic tables is the state of the element at room temperature. And this will add a little sentence about the key about solid, liquid, gas, and it'll show a graphic, because they have periodic tables that have little graphic. It's all either enlarge a key with a little drop of water or whatever. They have graphics to show that. It's another way to recognize characteristics. Also, I just have to remind them that although there are more phases, this is the room. This is the at room temperature. Yeah, well, here I'm reminding them. I forgot about that. Oh, yeah. So I will be reminding them that, yes, all the elements can be in all the phases or states of matter. States of matter. But they will not see it listed in anything but the state of matter at that set temperature, which is basically like room temperature. And to remind them that some things are different than they would expect. Like mercury is a liquid at room temperature, and there's another one that's interesting too. Now, valence electrons. I'm unsure, but I think I'm going to have to add a slide and explain this carefully, because on the periodic table there are the Roman numerals that they'll see across the top, which is good. And then it's a wrap. So then there's like a little quiz on their own. It's not interactive, though. I'm hoping to make this interactive. Goodbye. Yeah, these are the credits. Everything I got, I just kept putting in here. I don't know how to cite things properly. And that is the end. Here's the record button. How do you stop this? And stop.